In this video, we will do a quick revision for the topic Motion, Forces and Energy in IGCSE 0625 Physics syllabus. So here, the first topic is Motion, Forces and Energy, where we need to study physical quantities and measurement techniques. So first we can see what are the physical quantities mentioned in the syllabus and which are the measuring devices we can use. So the first physical quantity is length, and length can be measured using a ruler. You don't have to study about vernier caliper or screw gauge because it is removed from the latest syllabus. Next, volume. Volume can be measured using a measuring cylinder. Then different time intervals. Time intervals can be measured using clocks and digital timers. So you should be familiar with these physical quantities and how we can measure using these devices. Next, when we measure the volume, there are different methods. That is, first, if you have a irregular shaped object, or if you have a regular shaped object, in both cases, measuring the volume is different. If you have an irregular shaped object, we will use measuring cylinder. How can we use measuring cylinder? So here we can consider we have a stone which is not having a regular shape. So what we have to do is, as mentioned, we can use a measuring cylinder here. So first take a measuring cylinder. Using measuring cylinder, we can measure the volume of liquid, we know that, and which should be filled with a liquid. Now, initially measure the volume, that is initial volume, we can represent as V1. Then later what we have to do is, we have to immerse this object which is having a irregular shape, so that we can measure the volume of this object. When we dip this object in the liquid, we know that the water level will increase. So the water level will rise. So we will get a new volume. We can represent this one V2. So the volume of the irregularly shaped object will be the difference of these two volumes. That is the final volume of the liquid minus initial volume of the liquid. But if you have an object which is having a regular shape, for example, a cuboid that is having a regular shape, so we can use the formula to calculate the volume. A cuboid will have a length, this side is breadth, and it will have height. So the volume can be measured using the equation LBH. So for an object which is having irregular shaped object, you can use water displacement method, and for a regular shaped object, in order to calculate volume, you can use the formula. Next topic is determine an average value from multiple reading. This is also very important topic. So the value of multiple reading will be given. For example, first one, the thickness. So the thickness of multiple objects will be given. For example, the total thickness of stack of papers will be given. So the total thickness, let it be X. That is nothing but total thickness. And number of pages will also given. Let it be Y. And you need to calculate what is the thickness of a single page. So in this kind of question, we have to divide, as you need to calculate the thickness. You should write the thickness at the numerator. So the total thickness divided by number of pages. Always write the number at the denominator. Students get confused. They get confused to whether write number of pages at the top or bottom. Always write number at the bottom or at the denominator. Measuring the time period of a simple pendulum is also coming in this topic. Under this topic. So how to measure the time period of a pendulum? So first we can see what is pendulum. Pendulum is a bob connected to a thread and which is connected to a fixed end so that it is free to move like this. It can oscillate. And one oscillation means if you are considering this as the starting position, it will go to the one extreme position and it come back to its initial position, and it will go to the other extreme position and come back to the initial position. This movement is one oscillation. So the time taken for this one oscillation is known as time period, which is represented by capital T. So time period T of a simple pendulum is nothing but the time taken for one complete oscillation. In order to get an accurate value, instead of measuring one oscillation time, we can measure the time for 10 or more oscillations. Then we can find the average time or time for one oscillation. This is how we usually do. So as a formula we can write down time period is equal to total time taken divided by number of oscillation. So for example, a pendulum oscillates 10 times. So the number of oscillation is 10 and it takes a time of 5 seconds. So we have time and number of oscillation. What is the time period? So we have the formula. Time period is the total time taken divided by number of oscillation. Here the total time taken is 5 seconds divided by number of oscillation. There were 10 oscillations. So divided by 10. So you will get 0.5 seconds. So that is the time period or time taken for the bob to complete one oscillation. Topic number 4 is scalar and vector quantities. So you should know how we represent the value of a physical quantity. For example, temperature. So we will write temperature, that is the physical quantity, which is 40 degrees Celsius. So here basically it consists of the physical quantity, then a value. The value is known as magnitude. It will have a number, that is magnitude. Then degrees Celsius, as you can see, which is the unit. So basically this is how we represent any physical quantities, where we will have the physical quantity, the magnitude or the value which is represented in a number with a unit. So another example I am showing here, that is force. We can write the force acting on an object is 100 Newton, but we should mention the direction here. If it is towards right, the object will move towards right. But if it is towards left, object will move towards left. So we can write down force is 100 Newton towards right. Here again we can see we have this part is physical quantity and 100 Newton, where 100 is magnitude. Then it mentioned the direction also. We have to mention the direction, that towards right or left. So when we look at these two examples, we can see that in the temperature, this is a physical quantity. When we represent the temperature, we don't have to mention about the direction. Direction doesn't matter. We can measure the temperature of a glass of hot water in any direction. It will remain same. But for force, we have to mention the direction, because when the direction changes, the object will move in different directions. So force, when we represent, it required not only magnitude but a direction. Such physical quantities which has both magnitude and direction is known as vector quantities. But when you look at the temperature, we can see here we just need a magnitude. We don't have to mention the direction. Such physical quantities are known as scalar quantities. So here we can see physical quantities are of two types, either scalar or vector. So we have already seen scalar quantities are the quantities which have only magnitude. It's just a number. No need to mention the direction. But vector quantities are the quantities which have both magnitude and direction. Now you need to study some examples for scalars and vector quantities. If you think which physical quantities required both magnitude and direction, you can easily get that are the examples of vector quantities. So first we can start with scalar quantities. The examples are speed, time, mass, energy and temperature. These are the examples given in the syllabus, so you have to memorize. Examples of vector quantities are force, weight, velocity, acceleration, momentum, electric field strength and gravitational field strengths. Again, these examples are given in your syllabus, so you have to memorize. Next topic is finding the resultant of two vectors by calculation or graphically. And here you just need to find only how to find the resultant of two vectors. They are at right angles. So here, for example, two forces are acting on an object. The first force is horizontal, which is a 30 Newton force. As you can see, it is acting towards the right. And the second force acting on the same object is a 20 Newton force, which is acting vertically downwards. So when these two forces are acting on the object, what will be the resultant motion of the object? So we have to find the resultant of these two vectors. There are two methods. First method is by calculation, where you will get a right angle triangle, so you can use Pythagoras theorem. First you have to redraw these two vectors using head-tail method. That redraw the horizontal vector in the same direction as shown in the figure. In calculation method, you don't have to check the length, exact measurements. You just need to draw a rough diagram. So by calculation method, we can draw the 30 Newton. This is the question which has given. In the question, two different vectors will be given. They are acting at two directions. So first step, we have to redraw this one. That first I am going to redraw the 30 Newton force which is acting towards right. You don't have to take the exact measurements, only you should follow the direction. So you can see that is horizontally towards right. Then I have to draw the second vector, that is 20 Newton. I can see the 20 Newton force is acting downwards. So I should connect this one as a head-tail method. I should connect the second force to the head. The tail of the second force should connect the head of the first force, or the head of the second force I should connect to the tail of the first force. In such a way I should connect. So I have two options. I can connect here, so you can see head and tails are touching, or I should draw here. Again head and tail are touching. I should not draw here because tail and tail are touching. That is not a proper way. Or I cannot touch in this way. I cannot draw where head and head are touching. That is also wrong. When you redraw, the head and tail should connect. So this is one correct method. Now we have redrawn these two vectors in such a way the head is touching the tail of the other one, and we have followed the exact direction. 30 Newton is acting horizontally towards right. 20 Newton is acting vertically towards downwards. Okay, now the resultant is nothing but the third side. And the direction of the resultant, where head is here. So head should touch the head of the resultant. You can see tail is here, so the tail of the resultant should touch the tail of the other vector. Now, what is the value of this resultant? Here we can see this is a right angle triangle, and the resultant here is nothing but the hypotenuse. So we can use Pythagoras theorem. So hypotenuse is base square plus height square. That will be hypotenuse square. So the hypotenuse value will be square root of 30 square plus 20 square. So we will get 36 36 Newton. So that is the resultant of these two forces, 30 Newton and 20 Newton. The resultant is 36. But we need to calculate the angle. So this angle, if you need to find out this angle, that is the angle between the horizontal and the resultant. In that case, this is angle that we can represent theta. You can use SOHCAHTOA. So you can use tan. Tan theta is equal to opposite over adjacent, where tan theta is equal to opposite is 20 divided by adjacent is 30 Newton. So theta will be tan inverse of 20 divided by 30. So you will get the angle also. So by calculation method, you will get an accurate answer where you have to find the magnitude of the resultant using Pythagoras theorem, and you should find the angle using SOHCAHTOA. That is the application of maths. Next one, how to find the resultant for the same values using a scale drawing or graphically, where you should take a ruler, pencil and a protractor, and you should redraw this with exact measurements and direction. So first of all, you can redraw 30 Newton, but we know that we cannot draw a 30 centimeter line in order to represent a 30 Newton, or 20 centimeter line in order to represent a 20 Newton, because we don't have that much space on your paper. So what we have to do is, you have to decide a scale. Very important. 1 mark most probably you will get for deciding the scale. So the scale here, we can take 10 Newton is equal to 2 centimeter. So what will be the values? In order to represent 30 Newton, we should draw a 6 centimeter line. And in order to represent a 20 Newton, we should draw a 4 centimeter line. So we should decide a proper scale, and you should write it. It's very important. Now you can take a ruler and draw these lines. That is, in order to represent 30 Newton, you should draw a 6 centimeter line exactly in the given direction. So 30 Newton, that means draw a 6 centimeter line which represent 30 Newton, and that should be exactly towards right. Then you can draw the other vector, that is 20 Newton. For 20 Newton, we should draw a 4 centimeter line which should be downwards, and it should be exactly at 90 degrees. So take a protractor and make sure the angle is 90 degree vertically downwards. Draw a 4 centimeter line that represents 20 Newton. Then using the ruler, connect the third side. Then measure the length of the resultant, and we will get 7.2 centimeter. So we can convert back using our scale. That 2 centimeter is 10 Newton. Therefore 7.2 centimeter will be is equal to 36 Newton. So that is the resultant, and we need to find out the angle. So this is the magnitude of the resultant, 36 Newton, and angle from the horizontal line is this angle, that you can keep a protractor and measure the angle, and measure this angle theta using a protractor. So in the question, if they have asked you to draw graphically or using scale method, you should draw this way, or using calculation, you don't have to draw, but you can use the Pythagoras theorem. If both options are given in the question, always use calculation method, because it takes less time and you will get a accurate answer.